With just two bulldozers and a gigantic steel chain, humans can sweep away an entire forest in just a few minutes. Trees tens of meters tall are uprooted and collapse onto the ground, as if a massive storm had just torn through the area. For decades, as the demand for expanding farms and production land surged, countries searched for the fastest ways to turn dense forests into open land. From Australia and Brazil to vast agricultural regions across North America, a special technique emerged, using enormous ship anchor chains dragged through forests to knock down large numbers of trees in a single pass. And in today's video, join Mandarin Tech as we explore this controversial method of clearing forest land and the massive machines behind it. In the field of agricultural land development, one of the biggest challenges is removing thousands of large trees across vast areas in a short amount of time. If chainsaws or excavators are used, the process can take weeks or even months. As a result, engineers and agricultural developers began searching for a method capable of clearing an entire forest at once. The solution came from something that seems completely unrelated to forests: ship anchor chains. Anchor chains are designed to withstand enormous forces while holding ships in place under strong waves and harsh sea conditions. Each link is typically forged from solid steel, with a diameter of several tens of centimeters and weighing dozens of kilograms. A complete chain can weigh anywhere from 10 to 30 tons, making it strong enough to pull down large trees when dragged across a forest. To better understand how this method works and why it can flatten an entire forest in such a short time, let's take a closer look at how this system of bulldozers and massive anchor chains is used for large-scale forest clearing. This method typically uses two heavy bulldozers, such as the Caterpillar D8 or D9 models. The two machines move in parallel, spaced about 30 to 100 meters apart, with a massive chain stretched tightly between them. When both machines begin moving forward, the chain sweeps across the forest like a gigantic blade. Smaller trees are uprooted almost immediately. Larger trees may have their trunks broken, be pushed over, or be uprooted after being subjected to pulling forces from both sides. In many cases, the entire forest in front of the two machines collapses to the ground within just a few minutes. From above, the scene looks as if a storm has just swept through the forest. But instead of wind, the destructive force comes from a gigantic steel chain. Anchor chain clearing has been used in many regions around the world. What once drew widespread attention to this land clearing method was not only its power, but also its ability to process extremely large areas in a short period of time. In regions with vast terrain and dense vegetation, removing trees using conventional methods often requires a large amount of labor, machinery, and time. In contrast with a chain dragging system, a wide area can be cleared after only a few passes of the machines. Another advantage lies in its simplicity of implementation. Compared with many complex land clearing technologies, this method mainly relies on the pulling force of the machinery and the strength of the steel chain. Thanks to its relatively simple structure, operation and maintenance are also not overly complicated compared with many other specialized mechanical systems. However, the very power of this method has also made it one of the most controversial techniques. Unlike selective tree cutting, chain clearing often sweeps away all vegetation along its path. This means that many animal species lose their habitats, soil structure is disrupted, and natural ecosystems are rapidly altered. In addition, pulling down trees across large areas can make the soil more vulnerable to erosion during heavy rain or strong winds. These issues have led many countries to begin reconsidering the use of chain clearing. Since then, many types of specialized machinery have been developed to replace the more brutal land clearing methods of the past. These machines can push, pull, gather, or process vegetation across large areas quickly, while also allowing better control over the land clearing process before the area is put into production. In the next section, we will explore the machines that are taking on this role at modern land clearing sites. With powerful pulling force and a massive steel blade at the front, these machines can push, gather, and level large amounts of fallen trees, rocks, and vegetation in a short period of time. One of the most notable representatives of this group of machines is the Caterpillar D10. Introduced in the late 1970s, the D10 quickly became an icon in the heavy machinery industry. It is a type of bulldozer designed to work in extremely harsh environments, such as open-pit mines, large-scale construction sites, or forested regions. Unlike smaller bulldozers commonly seen on ordinary construction sites, the D10 belongs to the class of large bulldozers with superior size and pulling power. Because of this, it is often used for tasks that other equipment can hardly handle, from leveling enormous volumes of soil, opening paths through complex terrain, to clearing large areas of land. At the front of the machine is a gigantic steel blade designed to push soil, rocks, and vegetation forward as the machine moves. When operating, this blade resembles a slowly advancing steel wall, pushing the entire layer of soil, grass, and fallen trees into large rows across the ground. As a result, after only a few passes, an uneven area or land covered with shrubs can quickly be leveled and prepared for the next stages of processing. In many forest clearing projects, bulldozers such as the D10 are often used to gather the fallen tree trunks into large piles, clean the surface of the land, and create wide open spaces so that other machines can continue working. For many decades, machines like the Caterpillar D10 have played an important role in transforming undeveloped land into areas for agricultural production, resource extraction, or infrastructure development. From these machines, numerous modern technologies for forest clearing and land processing have continued to develop afterward. Meanwhile, some equipment focuses on another task that is just as important: pulling and moving massive tree trunks out of the working area. One of the machines that represents this task is the John Deere 768L Bogie Skidder. Unlike bulldozers, which are mainly used for pushing and leveling soil, skidders are specially designed to pull and transport extremely heavy objects in forest environments. In logging areas or forest clearing projects, this is often one of the most important machines for gathering and transporting large tree trunks after they have been cut down. This machine has an extremely robust design, with a large chassis, enormous wheels, and a high-mounted cabin that allows the operator to observe the entire working area among tree trunks and uneven terrain. A distinctive feature of the Bogie Skidder version is its 6-wheel system, instead of the 4-wheel design found on many traditional logging machines. This configuration helps distribute weight more effectively, increase ground traction, and allows the machine to move steadily even across muddy areas, root-filled ground, or sloped terrain. In large-scale forest clearing projects, skidders such as the 768L2 are often used to gather fallen trees, pull large logs out of the working area, or tow specialized land clearing equipment behind them. As they move across the ground, they can drag steel rake attachments or large disc systems that loosen the top layer of soil, pull up tree roots, and collect branches into long rows. Machines like the John Deere 768L Bogie Skidder may not be as famous as gigantic bulldozers, but in practice they play an important role in completing the forest land clearing process. It is precisely thanks to specialized machines like these that many of the heavy tasks in modern forestry can be carried out much more quickly and efficiently. One of the mechanized tools commonly used in land preparation work, from agriculture to landscape restoration, is the landscape rake. With a design similar to a giant rake, this implement helps clean the surface layer of soil by gathering small rocks, roots, and leftover plant debris remaining on the ground. In terms of operating principle, a landscape rake has a structure comparable to a massive rake with numerous sturdy steel teeth arranged in a horizontal row. When pulled or mounted behind agricultural tractors or construction machines, these teeth comb through the surface layer of soil, dragging materials such as small stones, roots, wood branches, dry grass, or plant debris left on the ground. This process gathers unwanted materials and pushes them into rows or piles, making them easier to remove afterward. A notable advantage of the landscape rake is its ability to clean the soil surface without excessively disturbing the underlying soil structure. The rake teeth usually act only on the shallow soil layer, pulling up small roots, stones, and debris while maintaining the stability of the soil beneath. This is particularly important in land preparation for planting or landscape renovation, where preserving soil structure helps reduce erosion and maintain the natural drainage capacity of the soil. In addition to removing unwanted materials, the landscape rake is also used to level and reshape the soil surface. As it moves across an area, the rake teeth can break apart large soil clods, drag loose materials, and redistribute them more evenly. As a result, the ground after treatment typically becomes smoother and more level, creating suitable conditions for planting crops, growing grass, or installing landscape features. In practice, the landscape rake is used in many different fields, including agricultural land preparation, lawn renovation, construction of internal access roads, and cleanup of land after construction. Thanks to its relatively simple yet effective design, this type of equipment significantly reduces the amount of manual labor required to clean and finish the soil surface. After a piece of land has been cleared, its surface is often still quite messy. Small tree stumps, broken branches, rocks, and uprooted vegetation remain scattered across the area. If not removed, these materials can interfere with later grading, farming, or construction activities. Therefore, one of the important tasks in the land preparation stage is collecting and moving the remaining materials on the surface. In many land clearing projects today, compact track loaders, such as the Kubota SVL95-2S, are commonly used to perform this task. The Kubota SVL95-2S is a compact yet highly versatile loader, designed to operate in a wide range of working environments. When equipped with a front bucket, the machine can gather various types of materials from the ground surface. During operation, the operator lowers the bucket close to the ground and drives the machine forward. The pushing force of the machine, combined with the shape of the bucket, helps collect soil, branches, small roots, and leftover plant debris into the bucket. Once the bucket is full, the machine can lift it and transport the material to a designated area for further processing. Instead of traditional rubber tires, the Kubota SVL95-2S uses a rubber track system. This design distributes the weight of the machine across a larger contact area with the ground, thereby reducing pressure on the soil surface. As a result, the machine can move more stably across various types of terrain, including soft ground, forest soil, recently cleared surfaces, or areas filled with roots and obstacles. The strong traction of the track system also helps the machine maintain stability while pushing or carrying heavy materials. In addition to collecting debris, the bucket of the Kubota SVL95-2S can also be used to level the soil surface. As the machine moves across the working area, it can drag pieces of wood, branches, and loose soil toward a single location, while also filling small depressions and roughly flattening the ground. This process helps make the cleared area tidier and easier to handle for the next stages of work. Although it is not a massive machine like heavy bulldozers, the Kubota SVL95-2S still plays an important role in the final stage of surface preparation. The emergence of specialized mechanized equipment has significantly transformed the way people handle and manage land in forestry, agriculture, and construction projects. Instead of relying on slow and labor-intensive manual work that often involves higher risks, these machines make it possible to complete large volumes of work in a much shorter period of time. They allow operators to clear vegetation, gather debris, level the ground, and prepare surfaces for subsequent activities in a more efficient and organized manner. At the same time, the use of machinery helps provide better control over the land processing process, reducing excessive disturbance to soil structure and minimizing the waste of natural resources. In a context where the demand for productive land, infrastructure, and economic development continues to grow, such mechanized equipment is becoming an indispensable part of modern land development and resource management. Clearing forest with anchor chains reveals an interesting truth about technology. Sometimes the most powerful solutions come from the simplest ideas. Today, many new technologies are gradually replacing large-scale clearing techniques like this, aiming to create a better balance between economic development and ecosystem protection. However, the story of chain clearing remains one of the most striking examples of how machinery and mechanical power can transform the landscape of an entire region. In the next part of the video, we will continue exploring other giant machines used to clear land, remove forests, and transform natural environments into vast production areas. If you enjoy stories about technology, industry, and the massive machines shaping the modern world, don't forget to subscribe to Mandarin Tech so you won't miss our upcoming videos. Thank you for watching and see you in the next exploration.